Now we'll start the new chapter. This is last chapter of physics, 12th chapter, sound or sound waves. Yes. So we hear the sound from human, birds, animals, vehicles, radio, TV, etc. All around us, there are sound waves. How do we define the sound or sound waves? Sound को कैसे या waves को कैसे define करते हैं? Other waves you have seen apart from the sound waves, what are the other waves? Electromagnetic waves are there. है ना? Light wave. Light is wave, which is electrical and magnetic energy. है ना? And sound waves are called mechanical waves because which it needs the medium, particles oscillates the mechanical energy in them, whereas light wave, it doesn't need the medium for their propagation. Light जो आती है sun से earth तक, है ना? It doesn't need the medium. It carries the energy from the source itself. It can move in the vacuum. So light wave is the electromagnetic waves which are non-mechanical, but we will be focusing on the sound wave only, which needs the medium. And there is lot of what is called lot of research going on. A lot of millions of dollars are put into the to improve the quality of sound wave, you know, by the music industry. Music industry spend a lot of money to have the good quality of sound from the devices. Nowadays, you see that cell phone and all, and the small speakers have the very good quality. Earlier, we used to have the bigger sound system. अभी भी है बड़े-बड़े sound boxes, but छोटे sound box में पहले इतनी अच्छी quality नहीं आती थी. We are not able to distinguish the sound even properly. But now the quality of sound has gone to the very high level. In fact, but good quality of sound can be produced by the smaller devices, even cell phone maybe. So sound waves are sound waves are the disturbance of medium. Sound wave is the disturbance of medium in which energy and momentum are transferred without the transfer of matter. Sound waves are called mechanical. It is the disturbance of the medium in which energy is transferred, energy and momentum are transferred without the transfer of matter. Matter transfer नहीं होता. जैसे suppose हम sound produce करते हैं, तो अगले the next person is able to hear it. That particles from near to the mouth doesn't travel to the other's ears. In fact, particles near the sound source, they start oscillating. They transfer the energy to the other one. Suppose यहाँ से sound produce की, ये oscillate करेगा, फिर इसको energy देगा, फिर next will get the energy like this. They will transfer the energy and momentum without they themselves going to the one place to other place. Air जो है ना, air will start oscillating near to the sound system, and this oscillations will be transferred to the next one, to the next one, to the next one. Particle will oscillate there only. They will not oscillate to the much distance. Hardly few milliseconds they will oscillate. Millimeter, in fact, millimeter, or less than even fraction of millimeter they will oscillate. Transfer the energy to the next one and next one and next one. Their energy is transferred without the transfer of matter. ठीक है? Mechanical waves भी बोलते हैं because it needs the particles, it needs the medium which have the mechanical energy, kinetic and potential energy. है ना? Sound waves are also called mechanical waves. तो production of sound देखो, ये oscillating tuning fork है. Take the tuning fork and set into vibration by striking its prong. इसको prongs बोलते हैं जो. These are called prongs. On rubber pad, bring it near to your ear, कान के पास लाओ ये oscillations, you can hear it. Do you hear any sound? Yes, you can hear it. Lab में रहता है ये, you can just ask that lab technician. They will give you. You can hit it onto the rubber pad. Rubber pad नहीं है तो कहीं और थोड़ा सा hard surface पे hit कर सकते हैं. Edge of the table पे तो ये prongs starts vibrating. Touch one of the prongs of vibrating tuning fork with your fingers and share your experience. You will feel the vibrations. को touch करते हैं ना तो fingers में vibrations और energy transfer होती है. Now suspend the table tennis ball or small plastic ball by the thread. यहाँ से suspend किया, ठीक है. And take a big needle and thread. इसको बना लो, needle वगैरह से होल करके थ्रेड बांध लो, है ना. And then touch the ball gently with the prongs of the vibrating tuning fork. Observe what happens and discuss with your friend. ये दूर भाग जाएगा, एनर्जी मिलेगी. मैकेनिकल एनर्जी, काइनेटिक एनर्जी will be transferred. वाइब्रेशन की जो काइनेटिक एनर्जी है, prongs of the tuning fork will be transferred to the ball. It will gain the kinetic energy, will move away, and kinetic energy converts into potential energy. Again, it will come back and hit. Again, it will go this way. So you can have the experiment of this activity. All right. तो दूसरी एक्टिविटी वाटर के साथ कर सकते हैं. Fill the water in the beaker or glass up to the brim. Brims mean up to the top. जो circumference होता है उसको brim बोलते हैं. Edge जो होती है. Gently touch the water surface with one of the prongs of the vibrating fork as shown in the figure. ऐसे टच करो तो देखो उसमें वाइब्रेशंस वाटर में कैसे ट्रांसफर हो रहे हैं नीचे की तरफ, है ना. नेक्स्ट डिप द प्रोंग्स बाय वाइब्रेटिंग ट्यूनिंग फोर्क इन द वाटर एज शोन. ऐसे टच करो तो एनर्जी ऐसे वाटर में वेव्स इधर बनती है. ऑब्जर्व व्हाट हैपेंस इन बोथ द केसेस, डिस्कस विद योर फ्रेंड. तो दोनों में वाइब्रेशन ट्रांसफर होंगे बट वेव्स विल बी डिफरेंटली फॉर्म. सरफेस पे बनेंगी या इस पर नीचे तक सरफेस पे बन के नीचे जाएंगी, इसमें लेफ्ट साइड इधर जाएंगी, फिर नीचे की तरफ ट्रेवल करेंगे. How sound waves are produced? Already I have explained you. Medium in contact with the vibrating object will be first displaced. यहाँ पर suppose tuning fork है, ये displace हो जाएगी यहाँ पर. ये वाले यहाँ पे जाके यहाँ पे जो मॉलिक्यूल होगा उसको टकराएगी, वो displace होगी like this. Energy will be transferred to the next and next. है ना. The medium in contact with the vibrating object is first displaced from the equilibrium position. अपनी mean position पे रहते ही ऐसे आप vibration शुरू हो जाएंगे, फिर इसको ट्रांसफर करेंगे तो वो आगे. It then exerts force on the adjacent particles that starts vibrating and process goes on. And quickly it is transferred to the next, and this disturbance will be transferred from one place to other place. Do you have how fast this disturbance will transfer? कितनी देर लगेगी उसको एक जगह से दूसरी? How fast is it transferred? In 1 second, in 1 second, how many meters it will be? This energy will be transferred. बोलो 1 second में कितना चला जाएगा disturbance or energy? Any clue? It depends upon the medium, whether you are doing the experiment in the air or in the steel rod or inside the water you are doing it. On that depends. Air में कितना चला जाएगा? Do you have? It will be roughly 340 meters. 340 meters. Roughly 331 meter होता है if temperature is 0 degree Celsius. Do you have this idea? इसका आइडिया था 330? किसने बोला 330?
सर मैंने. सिद्धांत.
सिद्धांत कहाँ पढ़ा था 330? The speed of light in the air.
ये सब पढ़ा है.
Speed of, just a minute.
सर
Speed
हमको
of
लास्ट
light.
ईयर मैम ने बताया था.
हाँ सर.
हाँ.
हाँ सर.
Speed of, yes, speed of sound in air is 331 at 0 degrees Celsius and increases by 0.6 meter per second with every 1 degree increase of temperature. So roughly 340 plus होता है normal temperature पर, है ना, जो surrounding temperature है, take it 25 or 27 or 30. तो लेकिन वाटर एयर में कम है, एयर में 331 0 डिग्री सेल्सियस पर, आई मीन 331 मीटर पर सेकेंड. स्टील में ज्यादा है, इट इज 5000 मोर देन 5000. मेटल में साउंड वेव्स आर डिस्टर्बेंस इज फास्टर, साउंड वेव्स आर फास्टर. वाटर में रफली 1450 मीटर पर सेकेंड. गैस में सबसे कम है, लिक्विड में थोड़ा ज्यादा है और सॉलिड्स में और ज्यादा है. तो इट इज क्वाइट ए फास्ट ट्रेवलिंग बट नॉट दैट फास्ट विद द लाइट ट्रेवल्स. साउंड जो है स्लो है, इसलिए व्हेन यू सी एनी फायर क्रैकर बस्टिंग और लाइटनिंग टेकिंग प्लेस एट सम डिस्टेंस, first you see the light, then you hear the sound, because both are simultaneously produced. Light travels faster, comes to you earlier, and then sound comes. And the sound is slow, light is very fast. How fast the light is? 3 into 10 to the power 8 meter per second. Quite a fast, huh? All right. Can sound make light spot dance? Yes, you can do this activity also at home. एक टिन कैन ले लो, उसको ओपन कर लो दोनों तरफ से, इधर से भी इधर से भी, है ना, कोकोला वगैरह जो भी आती टिन कैन जो कोल्ड ड्रिंक्स की. रिमूव बोथ एंड्स टू मेक इट hollow cylinder. Take a balloon and stretch it over the can. Then wrap the rubber band. यहाँ पे balloon को stretch कर लो ऐसा, और यहाँ पे rubber band लगा दो. ठीक है. Take the small piece of mirror, यहाँ पे छोटा सा mirror piece ले लो. Use a drop of glue to stick the piece of mirror to the balloon. Allow the light through the slit to fall on the mirror. यहाँ से देखो स्लिट है, छोटा सा कार्डबोर्ड में होल कर लो, इधर बल्ब से एक लाइट आने दो इधर. It will be reflected to the wall. यहाँ पे वॉल पे लाइट स्पॉट दिखेगा, है ना, as shown. Talk or shout directly into the open end of the can. यहाँ पर दूसरी तरफ से. The dancing light spot on the wall will be visible. यहाँ पे ये वाइब्रेट होगा अंदर बाहर, तो ये लाइट भी इधर, it will change its position. Discuss with your friends and make the light spot dance. ठीक है, तो ऐसे एक्सपेरिमेंट कर सकते हैं. तो लाइट जो है, या स्लिट मीन्स होल, पतला सा कट, जैसे सपोज ये कार्डबोर्ड है, तो ऐसा स्लिट कर लो, थिन कट, तो दैट उसकी लाइट यहाँ पर. अपने सेल बल्ब ले लो या सेल फोन की टॉर्च ले लो, सेल फोन का टॉर्च ऑन करके यहाँ से. ठीक है, तो मिरर से रिफ्लेक्ट होके it will vibrate, therefore dancing effect will be seen on the wall. Okay, this experiment you can do activity. Now propagation of sound. Sound, how does it propagate is explained here. These are called prongs, and tuning fork है. इसको रबर पैड पे हिट करो, वाइब्रेट कराओ. तो यहाँ पे जो एयर पार्टिकल्स है, when it moves outward, air particles come closer. तो यहाँ पे compression बन जाता है, pressure increases. C is called compressions. When this goes this side, यहाँ पर ओके ये कंप्रेशन आगे चला जाएगा इधर, इनफैक्ट यहाँ पे आ जाएगा, और व्हेन इट गोज व्हाट इज कॉल्ड इनवर्ड, तो एयर पार्टिकल्स यहाँ पर जब ये दूर जाएगा, देखो जब इनवर्ड जाएगा ऐसे, व्हेन इट इज गॉन इनसाइड इनवर्ड, यहाँ पर एयर पार्टिकल दूर दूर हो जाएंगे, यहाँ पर रेयर फ्रैक्शन बनेगा R, रेयर फ्रैक्शन। और ये जो पहला कंप्रेशन बना था ये वाला, दिस वन, it will come this side. Like this. फिर again when it comes inward, I mean come outward, फिर से एक compression बन जाएगा, फिर यहाँ पे रेयर फ्रैक्शन, फिर compression, like this, like this, you will have the compression near fraction alternate. ये आगे बढ़ता जाएगा, this is C, यहाँ पे फिर से yeah. So like this, due to vibrations of prongs of the tuning fork, you get alternately compression and air fraction. How do we define the compression? Compression is the part of the medium where the more density, pressure and density increases. Okay, we'll write separately. नीचे लिख रहे हैं. Compression and rare fraction की definition will write somewhere ahead. Somewhere लिखा है मैंने नीचे. तो compressions and air fractions are formed. In fact, जो air है, surrounding air, wherever sound is produced, the pressure of medium goes up and goes down from 1 atmosphere. Normally 1 atmosphere पे रहता है, and suppose nobody is talking in the room, air is at 1 atmosphere, but moment somebody talks, then near to that mouth, the sound waves are produced, the pressure of the air goes up whenever compressions are formed, है ना? And जब हम लोग ब्रीद इन करते थोड़ा गैप होता है, वहां पे कंप्रेशन रेयर फ्रैक्शन बन जाते है ना? तो alternately compression and air fractions are formed. Rare fraction is the less denser medium, pressure is also decreased there, वहां पे pressure will be less than 1 atmosphere, and this difference is not much. Suppose 1 atmosphere, you know how much big pressure it is? 1 atmosphere is roughly 1 lakh Pascal. So pressure difference will be hardly 20 pascals. तो 1 lakh में से one normal condition में जो air है 1 lakh Pascal. When we talk or when we produce the sound, the compression में जो pressure होगा say minus 20 Pascal less. Sorry, I mean rear fraction में, compression में plus 20. It is not increasing much, plus minus 20 or 30 SI unit of pressure difference take place at compression and air fraction. So like this medium is divided into parts. So how does the sound produced by the vibrating object in a medium reach your ear? तो ये जो vibrations है, यहाँ पे जो suppose we are listening it, यहाँ पे अपना कान है, ear है, तो यहाँ पर जो vibrations है, they are reaching to our ear वहां पर that vibrations are sensed by the by the what is called nerve system and hearing system of our body, and that signals are sent to the brain, and we can identify the sound, which kind of sound source is there, and who is calling us or who is just producing the sound, what kind of sound, whether birds are chirping or some radio or TV sound, or your friend is calling you, or you're listening to me. अभी भी जैसे मैं लेक्चर ले रहा हूँ है ना, तो आई एम स्पीकिंग इन फ्रंट ऑफ द iPad, है ना, microphones, my sound system is creating the pressure variation near to the iPad. That microphones picks up that signals, and microphone pick करता है उसके जो coil है that oscillates in the magnetic field. So that sound energy converts into the electrical energy. ठीक है, these electrical pulses goes inside the system. There is the oscillator. Oscillator produces the high frequency electromagnetic waves that makes up these sound waves, which are converted into the electrical form. Both the signals, both the waves are mixed up. In fact, our sound waves are superimposed on the electromagnetic waves, light, I mean radio waves, and these are transmitted to the towers, and tower will receive the signals, amplify it, and send it to the other tower and send it to your system, your cell phone or your Wi-Fi. And then what is done, that your that laptop or iPhone or whatever the instrument you are using, they are again demodulating it. मेरा जो है सिस्टम इज मॉड्यूलेटिंग, इसको मॉडिफाई कर रहा है, साउंड को इलेक्ट्रिकल सिग्नल्स में, इलेक्ट्रिकल सिग्नल्स को सुपर इम्पोज करके रेडियो सिग्नल्स के ऊपर sending to the tower with the speed of light. Don't you have the doubt now? The moment I speak, immediately it is coming to you. You may be 10 kilometers away from me, है ना? But immediately you are able to listen, है ना? And so what is happening? In fact, the sound signals are superimposed onto the radio signals, which move with the speed of light. इसको बोलते हैं मॉड्यूलेशन, है ना? फिर तुम्हारे पास when there's, are you there, तुम लोग हो लाइन पर?
Yes, sir.
Yes, sir.
Okay, when you are
Yes, sir.
when the my sound, which is superimposed, or which is loaded onto the electromagnetic waves, radio waves, when they reach to your instrument demodulates it. It takes out the sound signals again from that wave, radio waves, और फिर उसको वापस ओरिजिनल फॉर्म में कन्वर्ट कर रहा है. So you are able to listen my voice as the sound signals again, but in between they are chilled by the instruments, है ना? So therefore this is happening very fast because we are taking the help of radio waves. They move with the speed of light. The value which I gave you, 3 into 10⁸ मीटर पर सेकेंड. तो अपनी साउंड जो है ना, ये देखो साउंड वेव की फ्रीक्वेंसी कम होती है लाइक दिस, और रेडियो वेव्स आर क्वाइट फास्ट, फ्रीक्वेंसी इज वेरी हाई. इसको सुपर इम्पोज कर देते हैं और ट्रांसमिट कर देते हैं सिस्टम टावर्स की तरफ, है ना? तो दीज आर नॉट लेस देन एनी मिरेकल, है ना? थिंग्स आर दैट हार्ट्स माइट हैव नॉट थॉट कि उसने जो वेव्स बनाई थी, है ना, इलेक्ट्रॉन वेव्स, they will be of such a use that by sitting at home, and I am able to take the lecture and you are able to listen me, and also see other that news are coming quite fast, है ना? So every credit goes to him. ठीक है. So could you get some idea how the things are happening?
Yes, sir.
So when
Yes,
this
sir.
disturbance, okay, then when the disturbance of the vibrating air, now again your instrument is producing the sound and a microphone is producing the sound. Now air in front of the instrument, your laptop and whatever is there, it is producing the sound. Air in front of that is vibrating, and that vibrations are reaching to your ear. Suppose you remove the air from the gap between you and your instrument, then you cannot listen the sound. Ultimately, they are becoming the sound signals again, and you are able to hear it. बीच में जो मैकेनिकल जो वेव्स है, रेडियो वेव्स, दे डोंट नीड द मीडियम. अगर इंस्ट्रूमेंट एंड टावर के बीच में गैप कर दिया, वैक्यूम कर दिया, तो ना, देयर इज नो प्रॉब्लम. सिग्नल्स विल बी पासिंग, यू कैन हियर मी. बट इंस्ट्रूमेंट एंड माय माउथ, इनके बीच में एयर इज रिमूव्ड, or between you and your laptop air is removed, then you cannot hear me. Sounds are the mechanical waves, they need the medium for their formation and for propagation. Okay, so that's how they are produced and propagated and heard. Now the point which I was telling you just, it is now here. अभी ये point जो मेरा है, sound is now, sound is mechanical wave and needs a material medium like air, water, steel, etc. for its propagation. It cannot travel through the vacuum, which can be demonstrated by following experiment. तो ये experiment करते हैं इसको. This is the jar, bell jar, है ना? Cork fitted with the cork, and then electrical connections are there going inside, and this is the electrical bell, and here is the pump connected, pipe is there connected to the vacuum pump. So start the vacuum pump, take out the air, bahar. Now there will be vacuum, and vacuum pump से air निकाल लो jar के अंदर से, ठीक है? Then you supply the current. You see that this bell will be ringing, means you can see that this striker is vibrating and hitting the bell, metal bell, but you cannot hear the sound, no sound. Why? Because vacuum है यहाँ पर. When it पहले do the experiment with air field, you can listen the sound. Air particles oscillating and hitting these bell jars, and then sound is, it is vibrating and sound is able to reach you. Yeah, it will vibrate, air will vibrate again adjacent to the bell jar, and you can hear the sound. But moment you remove the air from the jar, so it will be functioning. You can see it operating, but no sound. So it is mechanical waves needs the vacuum for their propagation. So this experiment can be done provided you have the vacuum pump. Okay. So my question is this. Let me ask you one question. There is explosion at moon. In what time it can be seen and heard? It can be seen, and in how much time sound can be heard? If distance is d, यहाँ पर अर्थ है. Okay. Here is the moon. दोनों के बीच में डिस्टेंस कितना है? d. Speed of light is c. Speed travel with the speed c, and speed of sound is v. कितनी देर में हमें लाइट दिखाई पड़ेगी? यानी जो एक्सप्लोजन हुआ, लाइट कितनी देर में आएगी और साउंड कितनी देर में आएगी अर्थ पर? बोलो पहले कौन सा लाइट का है? फर्स्ट पार्ट का आंसर, देन सेकंड पार्ट. क्विक आंसर. टाइम निकालना ना, टी. इन हाउ मच टाइम इट विल टेक. आदित्य तुम लोग हो? आदित्य पहले लाइट का
Yes, sir, yeah.
लाइट
Sir,
कितनी देर में
device.
पहुंचेगी? D by
D by C.
T1 is D by C. Is it okay? Shubhan, D by
Yes,
C is
sir.
okay.
Yes, sir.
Siddhant and Kishan. Okay,
Yes, sir.
second part. Second part. First Kishan will tell, then Shubhan, then Adit, then Siddhant. Well, second part का आंसर T2. Okay, anybody can reply.
Sir, D by V.
D by V. Whose answer? किसने
Sir,
दिया?
Shubhan.
Because एक Shubhan का आंसर D by V. Others, Shubhan is D by V. Okay.
Sir, D by V.
Adit, D by V.
Yes, sir.
Kishan and Siddhant. बोलो.
Sir, D by V.
Oh, yes, sir.
When there is
vacuum.
vacuum is there between most of the space is
Yes,
no
sir.
medium. है ना? There is vacuum. So sound cannot reach to the earth. You can only see the explosion taking place. Sound will never come. है ना? After say few hundred kilometer above the earth's surface, there is no atmosphere. है ना? Few hundred kilometer तक है, roughly 400 kilometer तक है ना? उसके बाद से पूरा vacuum है, because of that effect of gravity decreases. Molecules will escape. जो ऊपर वाले gas molecules हैं, moment temperature goes up, they will no longer be there and they will escape. है ना? तो after that vacuum is there. है ना? और मून पे क्या है? मून पे तो escape velocity is more than the RMS velocity is more than the escape velocity. There is the gas की जो velocity होती है, root mean square velocity, that decides. Moon पे it is large than the escape velocity because of gravitational force is less there. Moon पे तो atmosphere है ही नहीं, almost no atmosphere. Earth पे gravity is strong and therefore escape velocity is more, RMS velocity of gas particle is less. They are not able to escape. Moon पे they are able to escape. Even surface itself, surface से ही escape हो जाते हैं. है ना? Gravity is less there. So no atmosphere. But most of the space is filled with the vacuum. है ना? How do we breathe in air? Of course, aeroplane वगैरह में तो artificial air is there है ना? Pressurized chamber रहता है, height पे जाने से है ना? Even if what is called height is much lesser as compared to 400 kilometers. कितनी की aeroplane कितनी height पे उड़ते हैं? वहां पर भी प्रेशर कम है, काफी ऑक्सीजन कम हो जाती है. And even on the earth itself, if you happen to go to the Mount Everest, you have to carry your own oxygen bottles because oxygen is less at that height. कितनी height है Mount Everest की summit?
Sir, 848. 8848.
848,
Meter.
nearly 9 kilometer only है ना? In kilometer it is roughly 9. तो वहां पर ये ऑक्सीजन कम है. एरोप्लेन कितनी हाइट पर होता है? पैसेंजर प्लेन्स आर एट व्हाट हाइट? roughly 10 kilometer. कितना? 36,000 feet.
30,000 feet, yes.
33 or 36,000. उसमें भी वो रहता है ना,
So
going
30,000
towards
feet.
30,000 feet.
Average.
Depend upon in which direction they go. Suppose
Yes, sir.
flying from east to west, if they are 30,000 feet, west to east, they will be say 5,000 or 10,000 feet up or down, so that there should not be collision in mid-air. है ना? एक particular direction से they maintain some height. Going to east will be at certain height, going to west will be some minimum distance they have to keep, so that there should not be head-on collision. है ना? So certain, so there 33,000 mean divided by roughly 10,000 kilometer. है ना? या 10,000 किलोमीटर वही नहीं, एक मिनट 33
10 kilometers.
10 किलो कितना आ रहा है 10 किलोमीटर
हाँ सर.
और माउंट एवरेस्ट ये 9 किलोमीटर नहीं, उससे ज्यादा होगा
Yes.
हाइट विल बी मोर. ठीक है, बट दैट माउंट एवरेस्ट इज स्लोली, इट इज ग्रेजुअली, इट इज इंक्रीजिंग हाइट ना. एनीवे, चेक अप एंड टेल मी व्हाट इज द हाइट ऑफ द पैसेंजर प्लेन एंड माउंट एवरेस्ट से कितना डिफरेंस है उनकी हाइट में, लेवल में, है ना. तो एट सच हाइट्स itself oxygen level is down. How do we get the oxygen? Aeroplane के अंदर कहाँ से मिलती है? You don't have to use the mask there. Plane के अंदर it is completely sealed, है ना? Pressurized air is there. अंदर जो है it is pressurized to 1 atmosphere. You cannot take the helicopter at that height and just inhale properly. हेलीकॉप्टर ज्यादा हाइट पे नहीं जाते हैं ना, because they are not sealed and pressurized. Aeroplanes are sealed completely and pressurized. Artificially, oxygen is maintained there. ना?
Yes sir.
All right. तो ये हो गया. Next is the questions. I think link will break again. We have to join. हो गया, कितना टाइम बचा है?
Sir, less than 1 minute.
चलो, we'll join again. We'll join for the next further. Okay, चलो.